Welcome to my channel. My name is Bhawa Singh. Today we're going to discuss Round 3 DevOps interview questions on CI/CD. You might have already seen Round 1 and Round 2 of CI/CD interview questions. If not, make sure to check them out. I'll drop the links in the description. Trust me, you don't want to miss the foundations before we tackle the trickier builds in this one. So buckle up, whether you're prepping for a DevOps interview or just trying to sharpen your CI/CD game. Oh, and if you're enjoying this series, don't forget to like, subscribe, and share it with your DevOps gang. Ready to build your interview confidence? All right, guys, let's dive into our third round of interview questions on CI/CD. Today, our first question is, what are artifacts in a CI/CD pipeline? Artifacts are the output files or products generated during the build or packaging stages of a CI/CD pipeline. These are the things your pipeline produces and passes along to later stages, like testing, deployment, or release. Let's take a look at some common examples of artifacts in a CI/CD pipeline. Compiled binaries or executables, like .jar, .war, .exe, and so on. Docker images, zipped code packages, for example, a .zip file containing your .jar or .war. Another example is test reports, like unit test results or coverage reports. Configuration files, such as environment-specific files like config.yaml, application.properties, .env, or settings.json. And finally, log files or debug data. These artifacts are critical for ensuring smooth delivery and reliable deployment in your CI/CD workflow. Now let's switch to a visual summary, so you can screenshot this if needed. Our second question today is, how do you implement an effective and successful CI/CD pipeline? If you want to build a truly effective CI/CD pipeline, you need to focus on a few key pillars: strategic planning, smart tool selection, and strong automation. Here's a step-by-step breakdown. First, use a version control system like Git, GitHub, GitLab, or Bitbucket for all your code. And make sure to implement a solid branching strategy. Feature branches, a main or master branch, and a dedicated develop branch. Second, automate your build process. Trigger builds automatically on code push or pull request. Validate your code with linting, compile it, and package it into artifacts. Third, run automated tests. Start with fast unit tests right after build, then move on to integration tests after packaging. You can also run end-to-end tests before staging or production. Fourth, use an artifact repository. Store your build outputs, like .jar files or Docker images, in Artifactory, Nexus, or even AWS S3. Fifth, automate your delivery pipeline. Enable continuous delivery to staging and production. Use infrastructure as code tools like Terraform to manage your environments. Sixth, introduce approval gates. These can be manual or automated, depending on your CD model and level of risk. Seventh, integrate monitoring tools, like Prometheus, Grafana, or Datadog, directly into your pipeline. And don't forget to set up rollback strategies like blue-green deployments or canary releases. Eighth, secure your pipeline. Use secrets managers like Vault or AWS Secrets Manager and scan your code and dependencies for vulnerabilities with tools like Snag or Trivy. Ninth, optimize for speed and feedback. Use parallel jobs, caching, and lightweight containers. And make sure to send build or test notifications to your team via Slack or email. And that's how you build a high-performing CI/CD pipeline. Step by step, slide and screenshot time. Let's move to our next segment. We've got 4 CI/CD interview questions on the screen. While they may sound similar, each one focuses on a different angle of implementation. Now, we've already covered effective and successful CI/CD pipeline implementation question earlier. That one focused on best practices for building an effective pipeline, so we'll skip that for now. Let's dive into the first three questions, which are more scenario-based. These types of questions are where your personal experience really matters. Remember, tools and strategies vary from company to company. Always answer based on your environment, but here's how I'd answer them, using common tools and structure. Take a look at this slide. This is how you need to answer the question. How to set up a CI/CD pipeline from scratch. This question tests your implementation knowledge. So here's how I'd set up a CI/CD pipeline. From scratch, step 1, I start by setting up a Git-based version control system, usually GitHub or GitLab. Step 2, I define the build pipeline using GitHub Actions, GitLab CI, or Jenkins. It depends on the project's tech stack. Step 3, I configure the CI to trigger on every push or pull request. It runs linting, installs dependencies, and builds the application. Step 4, I include unit tests and integration tests to validate the build. Step 5, the build outputs are packaged and stored in a repository, like Nexus or AWS S3. Step 6, the CD pipeline then deploys to staging. For production, I configure manual approvals or gated releases. Step 7, I integrate monitoring tools like Prometheus and Grafana. I also set up rollback strategies, such as blue-green or canary deployments. The key here is automation, reliability, and continuous feedback at every stage. Take a look at this slide. This is how you need to answer the question. Have you implemented CI/CD from scratch? What were the key steps? This one's about your real-world ownership and decision-making. So here's how I'd answer it. Yes, I've implemented CI/CD from scratch for a Node.js-based application. It was a project moving away from manual deployments to a fully automated pipeline. First, I selected GitHub Actions for CI. It was easy to integrate and cost-effective. For CD, I used AWS S3 and Code Deploy. Second, I created workflows that triggered on-pull requests and main branch merges. Each job, build, test, and deploy, was defined in YAML. Third, I wrote unit tests and contract tests to ensure quality across microservices. Fourth, I integrated AWS Secrets Manager for credentials and used Trivy for vulnerability scanning. Finally, Code Deploy handled deployments to staging and production. I also added Slack notifications for every build and deploy event. I owned the full pipeline, collaborated with QA for test coverage, and worked with DevOps to manage infrastructure as code using Terraform. Take a look at this slide. This is how you need to answer the question. Describe the structure of a CI/CD pipeline you've implemented. This question is all about your actual project experience. Here's a real pipeline I built using GitLab CI/CD for a microservices-based app. Stage 1, Code Management. We used GitLab for version control. Branches were structured as feature, develop, and main. Stage 2, Build and lint. Every merge request triggered the pipeline. It ran lint checks, compiled code, and generated Docker images. Stage 3, Testing. Unit tests ran in parallel containers, followed by integration tests using Docker Compose. Stage 4, Artifact Storage. We pushed Docker images and jar files to GitLab's registry and Nexus. Stage 5, Deployment, CD. The delivery pipeline deployed to a Kubernetes staging cluster using Helm charts. Stage 6, Approval Gate. Production deployments required manual approval, and we used Helm rollbacks in case of issues. Stage 7, Monitoring. Post-deploy monitoring was handled using Prometheus and Slack alerts. The result? Faster releases, fewer errors, and full visibility across the pipeline. Slide and screenshot time. Let's move on to our next question. How do you choose the right CI/CD tool? Well, choosing the right CI/CD tool depends on your project needs, team size, budget, and infrastructure. Here's a simple, step-by-step guide to help you make the right choice. First, assess your project requirements. Understand your tech stack, deployment targets, and existing tools. For example, are you using Docker, Kubernetes, or just basic scripts? Do you deploy to the cloud, like AWS, GCP, or Azure, or on-premise? Second, define your team and workflow needs. Consider collaboration, roles, approvals, and how your team works. For example, do you need role-based access, approvals, or parallel builds? Do you support multiple environments, like dev, staging, or prod? Third, check tool compatibility. Make sure the CI/CD tool supports your programming languages, platforms, and frameworks. Does it support your repo host, like GitHub, GitLab, or Bitbucket? And does it work well with your build tools, like Node.js, Maven, or Python? Fourth, decide between cloud-based or self-hosted. Cloud-based tools like GitHub Actions or Circle CI are easier to set up and scale, but self-hosted tools like Jenkins offer more control, with a bit more maintenance. Fifth, evaluate ease of setup and use. Choose a tool your team can learn and use quickly. Does it have good documentation? Can non-DevOps team members understand it easily? Sixth, look at community and support. A large user base means more plugins, better help, and regular updates. Is the tool actively maintained? Is there community support on forums, GitHub, or Stack Overflow? Seventh, check pricing and limits. Make sure it fits your budget, especially if you're a startup or working on open-source projects. Are there free tiers? Does pricing scale with usage, like build minutes or number of users? Eighth, consider security features. Protect your secrets, your builds, and your deployment pipelines. Does it support encrypted secrets, access control, and audit logs? Ninth, ensure scalability. Can it run many builds in parallel? Is it easy to scale agents, nodes, or upgrade plans? And finally, 10th, test with a small project. Try the tool on a sample project to see if it fits your workflow. It's the easiest way to know if it's right for your team. And there you go. 10 steps to help you pick the right CI/CD tool with confidence. Our next question is, how do you manage secrets in CI/CD? All right, managing secrets like API keys, tokens, and credentials in your CI/CD pipelines is critical to maintaining the security and integrity of your application and infrastructure. So here's a structured approach to help you manage secrets securely. Step 1. Use built-in secret management features. Most modern CI/CD platforms offer secure encrypted storage for secrets. For example, in GitHub Actions, use secrets at the repository or organization level. In GitLab CI/CD, use CI/CD variables with masking and protection. In Circle CI, use environment variables. In Jenkins, use the credentials plugin. And in Bitbucket pipelines, use repository variables. When using these built-in features, follow these best practices. Store secrets as encrypted environment variables. Mark them as masked and protected to avoid exposure in logs. And never, ever, hard-code secrets in your code or configuration files. Step 2. Use external secret managers for more control. For more flexibility and enterprise-grade security, use dedicated secrets managers. Some popular options include HashiCorp Vault, a powerful enterprise-grade secrets manager. AWS Secrets Manager, fully managed with IAM integration. Azure Key Vault, for managing secrets, keys, and certificates. And Google Secret Manager, the managed solution for GCP, to integrate these tools with your pipeline. Use plugins, APIs, or command line tools to fetch secrets at runtime, and authenticate your runners securely using IAM roles, workload identity, or OIDC tokens, not hard-coded credentials. Step 3. Avoid common mistakes. Here's what not to do. Don't commit .env files or secret values to source control. Don't echo secrets into logs, even in debug mode. Don't reuse the same secrets across environments, like dev and production. And never share secrets through chat, email, or screenshots. Step 4. Follow security best practices. Adopt these security-first practices. Use least privilege access for every secret. Rotate secrets regularly to minimize impact if something leaks. Log and monitor all secret usage for auditing and alerts. And always use service accounts, not personal credentials, in your pipelines. So, whether you're using built-in platform features or external tools, the key is to treat secrets as first-class citizens in your CI/CD strategy. Stay secure and automate wisely. Slide and screenshot time. And that wraps up round 3 of our CI/CD deep dive. In this session, I tackled some of the most practical and technical aspects of real-world DevOps. I started by understanding artifacts, what they are, how they're used, and why they're crucial to the pipeline. Then I explored how to build a CI/CD pipeline from scratch, from planning to implementation, and broke down its structure, stages, and key steps. I also shared best practices for making your pipeline robust, efficient, and secure, whether you're scaling up or just getting started. Choosing the right CI/CD tool. I gave you a simple, structured approach, from evaluating compatibility to assessing ease of use and community support. And finally, I covered a critical topic: managing secrets in CI/CD. From built-in tools to external secret managers, I showed you how to keep your credentials safe and your pipelines secure. Whether you're building pipelines, refining processes, or choosing tools, you now have a stronger foundation to make confident, secure, and scalable CI/CD decisions. Thanks for tuning in, and as always, stay curious, stay secure, and keep shipping smarter. See you in the next round. Thanks for watching DevOps by Bawasi. If you found this helpful, don't forget to like and subscribe for more DevOps and real-world how-to content. Until next time, keep learning, keep deploying.